Hello friends, today I am going to discuss the one of the most important unit operation which is known as a size reduction. As you know that you are going to study almost 10 unit operations throughout your B.Pharm curriculum and size reduction is one of them. Let's try to understand the meaning of the word size reduction. If we try to understand the meaning of the word size reduction can be defined by the different terms having the different terminology. The first one that's called as a comminution. It is action of reducing a material or a ore to the minute particles or the fragments. It means we are trying to reduce the material to the either minute particles or its fragment or the pieces. It is known as a comminution. Another term which is used commonly for the size reduction which is known as a micronization, into which we are reducing the particle size or the average diameter of the solid particle to the micron level, and as you are knowing that the 1 micron is equal to 10 to minus 6 meter. The milling is another term which is used in the size reduction. The milling is generally used when we are using to cut or the shape any of the metal particles or the metals using a rotating cutters. And the another term that is the synonym of the size reduction which is known as a pulverization, which means crushing or the grinding. Before going the details of the understanding the meaning of the word size reduction, let's try to start with the first word which is known as a size. What is size? The size is the maximum distance between the two extreme points of a particle or the globules. As I told you earlier that it is usually measured in the terms of micron, that is 10 to minus 6 meter. The particles may be spherical or the globules or the droplet. Then in this case we are considering the diameter. The diameter, that is again the maximum distance between the two extreme points, and the diameter is taken as a particle size over here. But in the case of non-spherical particle or the irregular shaped particle, into which we find the maximum length between the two extreme points of the particle, and this maximum length between the two extreme points is considered as a size. So the size can be measured by either of the way in the terms of for the spherical particle as well as the non-spherical particle. Generally, if you are talking about the pharmaceutical industry, then the pharmaceutical industry basically classified to two industries. That is called as the first one that's called as a bulk drug industry, which generally produces the active pharmaceutical ingredients. What's the meaning of this one? As for example, we all are about the word paracetamol tablets. In this, paracetamol is considered as an active pharmaceutical ingredient or the drug. These bulk drug industries are going to supply this API to the pharmaceutical industries, and these pharmaceutical industries are going to be use this API to produce the various doses from like tablet, capsules, etc. So when they are supplying this bulk drug in the form of powder, there are certain problems are there. All these pharmaceutical powders are of the different size. What it means these powders are having the particles of the different size. It means they are the poorly dispersed in the nature, and which creates the difficulty into the production or pharmaceutical manufacturing. So the solution to this problem can be also done by the size reduction. Make all this pharmaceutical powder or the particles of the same or the one size. So try it by the means of size reduction. We try to make this polydispersed pharmaceutical powder into the monodispersed, and we can prepare the doses from them very easily. Now let's try to understand what is exactly happening with the size reduction. So here I have taken the one example of a solid or the large mass that is represented by a cube. As we are knowing that the cube is having the 6 sides, so when we are going for the size reduction of this cube, okay, it is going to be divided. It is going to be divided into this 8 small cubes. So by the means of this one, what we are doing, every time when I divide the one big cube into the small 8 cubes, I am going to increase the small masses and I am going to increase the surface area. Now let's try to understand this example of the size reduction of the cube in the terms of mathematical aspects. Let's say define the size that is the what we can say the length of the side of a tube is represented by the small a, and then that's why for this big tube, if I want to find the surface area, then the surface area can be represented by the formula that is 6a square. When I'm going for the size reduction and I'm getting the 8 different small cubes, it means I have reduced the surface area, reduced the length of the side of a cube from A2 to A over 2. And if I want to find out the surface area of the small cube, then it will be the 6a over 2 whole square. So it will give me the 6a square divided by 4. So that is equal to 1.5a square. And this 1.5a square represents to the surface area of the one of the cube. Here I have made the 8 cubes. I have reduced I have go from the size reduction of the bigger cube into the small a cube. So in this case, the surface area what I am getting, that is 8 times 1.5. So I am getting the 12a square. So under this condition, I have increased the surface area from the 6a square to the 12a square, which can be mathematically proven by this particular slide. So here almost by going for the size reduction, not I increased the surface, but I also made the surface area double. Now, why we are going to study the size reduction into the pharmacy field? The size reduction has some of the applications or the importance. The applications, the importance highlighted into this particular slide. Let's discuss these applications or this importance of the size reduction one by one. The first one, it will give the uniform flow. Means if I go for the particle size reduction, and if I'm getting the powders into the narrow particle size distribution or the particle powders having the same size, that is what we are calling as a monodisperse. So in this condition, the powder will flow uniformly. Second, if I am getting the uniform size particles, then in this case, I can also able to achieve the uniformity of the drug content throughout the tablet or the capsule. Now, what is meaning of this one? It means that my drug particles are very well distributed throughout the tablet or the capsules or any of the dosage form. Another one, that is the importance of the size reduction, will be the improved stability of the suspension. A suspension generally contains the liquid into which the particles will be in the partly soluble or the insoluble form. So the ideal stable suspension into which these particles should be suspended throughout the shelf life. In the early stages, if the particle size is more, then the particles of the insoluble solid particles will settle down very rapidly, and later on it lead to the sedimentation. It means that you find the both the phases are going to be separated. The supernatant is consist of the clear liquid, while the sediment is consist of the insoluble solid particles which has been settled down. So in able to avoid this one, we try to reduce the particle size, and that by reducing the particle size, we try to keep the particles in the suspended state as far as possible. The next important applications of this size reduction, that is by the going this reduce the size reduction, as I shown by this particular again the cube over here, which has been divided into the small 8 cubes. I am going to increase the surface area, and as I am going to increase the surface area, this all the surface area are going to come in the exposed in the come in the contact with that heating device or with the higher temperature, and due to which I can get the increase the rate of drying, as well as it's shown over here. The entire one tablet was there, that was divided into the 2 parts, 4 parts, and later it is crushed down into the small particles. So in this case, I can increase the extraction of the drug very faster, and thereby we can increase the reaction rates. So it means that whenever the particle size is smaller, I can find the rate of drying, extraction, and the reaction rate is going to be increased. Another important applications of this size reduction, it means by reducing the size of the particles. Here what I can say that the particles of that solid will come into the contact with the liquid very easily, and due to the smaller particle size and larger surface area, it is going to be dissolved very fast, and thereby it will increase the dissolution. And if such a solution of the drug will come into the contact with the intestine structure or in the large intestine or the small intestine, these drugs or particles from the solution, they are going to be absorbed very faster. So in nutshell, they are going to also increase the dissolution rate, and the absorption. So, friends, today I discussed about the basics or the introduction of the site reduction, and in the next coming video, I will also go into the much more details of the remaining aspects of the site reduction as well as the remaining all the unit operations. So if you like my video, then please click on the like button and please subscribe my video by clicking on the subscribe button or on the bell icon. So in the future, whenever if newer videos are going to be take place, so you can have that same one. Thanks.